Hello friends, welcome to my channel. This is Fluid Mechanics paper, part 15, Isro question paper from 2006 to 2016. Question is, the model of a propeller 3-meter diameter cruising at 10 meter per second in air is tested in a wind tunnel on a 1:10 scale model. If thrust of 50 Newton is measured on the model at 5 meter per second wind speed, then thrust on prototype will be how much? First we will write the data given. The model of a propeller. So prototype diameter. So prototype diameter is 3 meter and cruising at speed. Velocity of prototype 10 meter per second and scale is 1:10. LP by LM, length of prototype into length of model, it's 10. If thrust of 50 Newton is measured on the model, so thrust force Fm, force on that model 50 Newton, then velocity of model also given 5 meter per second. Thrust on prototype, we have to calculate Fp. Drag coefficient CD model equal to CD prototype. So CD equal to F by half rho a V square. So F of model by half rho a V square of model equal to Fp by half rho a V square of prototype. Half rho cancel. So we got F by a V square of model equal to F by a V square of prototype. Area is length square, so Fm by Lm square into Vm square equal to Fp by Lp square into Vp square. Fp equal to Fm into Lp by Lm square into Vp by Vm square. So put the values. Fm is force on that model is 50 into Lp by Lm, it's 10 square into Vp by Vm, 10 by 5 square. So 50 into 100 to 2 square is 4. 20 into 10 to the power 3 Newton. So from option A is our answer. Water having kinematic viscosity of 0.01 stroke flows at a velocity of 2 meter per second in a pipe of 15 centimeter diameter. For dynamic similarity, the velocity of oil of kinematic viscosity of 0.03 stroke in a pipe of same diameter will be dynamic similarity. So similarity of forces at the corresponding points. In the flow. So in data given, kinematic viscosity of water is 0.01 stroke. Then velocity of water is 2 meter per second. Diameter d equal to 15 centimeter. For dynamic similarity, kinematic viscosity of oil is 0.03 stroke. We have to calculate velocity of oil. So for dynamic similarity of forces, Reynolds number of water equal to Reynolds number of oil. So we know Reynolds number is V into characteristic length into kinematic viscosity divided by kinematic viscosity. So VL by kinematic viscosity of water equal to VL by kinematic viscosity of oil. Same diameter, so characteristic length cancel. We have to calculate VO. VO equal to velocity of water into kinematic viscosity of oil by kinematic viscosity of water. It's 2 into 0.03 divided by 0.01. So 2 into 3, 6 meter per second. From option D is our answer. An inclined plate 2 meter long and 1 meter wide lies with its length inclined at 45 degree to the surface of water, and its nearest edge is 1 meter below it. If specific weight of water is 1000 kg per meter cube, then total pressure force on the plate in kg is approximately how much? Pressure force in kg. Here this is theta is 45 degree, inclined plate of 2 meter long, and width is 1 meter, lies with its length. So nearest edge is this distance, 1 meter below it. Specific weight of water is rho g. Its density 1000 kg per meter cube. Total pressure force on the plate we have to calculate. And here the center of gravity is G. This distance is h bar. We know force equal to rho g a h bar. Here in kg, so rho a h bar. H bar is, this distance is 1 meter. One plus 1 into sine 45 degree. So 1 plus 1 by root 2. So root 2 value is 1.41. 41 plus 1 by 1.41. 2.41 by 1.41. So h bar we got, rho also given, only area. H we got 2.41 by 1.41. For approximation it's 240 by 140. 24 by 14. This is 14. Then F in kg equal to rho 1000 into area is 2 into 1. Then h bar 24 by 14. 7. 24 by 7. 24 by 7 is 3.4. So 3.4 into 1000. 3400 kg. So from option 3400, this one, approximately D is our answer. Here in this question lies with its length, so it is 2 meter. Otherwise if it will tell lies with its width, then this length will become 1 meter. So careful, you have to check the question first. A liquid of density 1200 kg per meter cube is flowing steadily through a tube of varying cross section as shown below. The cross section at point A is 1 centimeter square and at B is 20 mm square. The points A and B are in the same horizontal plane. The speed of liquid at point A is 10 centimeter per second. The difference of pressure at A and B is how much? Let at A point it's 1 and at B point it's 2. A as 1, B as 2. We will apply Bernoulli's equation here. First, data given are 200 kg per meter cube. The cross section of point A1 is 1 centimeter square and at B 20 mm square. So 20 by 10 square is 100 centimeter square. And speed of liquid at point A, V1 is 10 centimeter per second. We have to calculate P1 minus P2. Options are in Newton per meter square, so all units we have to take in meter square, and so you convert this one 1 into 10 to the power minus 4 meter square, and here 10 into 10 to the power minus 1, 10 into 100, 10 by 100 meter per second. Here 20 into 100 into 10 to the power 4, so it's 10 to the power 6 meter square. This is minus, so A1 equal to 10 to power minus 4 meter square. A2 is 20 into 10 to power minus 6 meter square. V1 is 10 into 10 to power minus 2 meter per second. To calculate V2, continuity equation we have to apply. A1 V1 equal to A2 V2. So V2 equal to A1 by A2 into V1. Cancel, then 2 equal to 10 by 20 or 0.5 meter per second. Again we will apply Bernoulli's equation. Here Z1 Z2 same, so P1 minus P2 by rho g equal to V2 square minus V1 square by 2g. G cancel. P1 minus P2 equal to rho into V2 square is V2 already we got 0.5 square minus V1 is 10 into 10 to power minus 2, it's 0.1 square by 2. 1200 by 2 into a square minus b square. 0.5 plus 0.1 into 0.1. 600 to 6 into 0.4. So 6 by 10, 4 by 10, 0000 cancel. 36 into 4, 144 Newton per meter square or Pascal. From option C is our answer. 144 Newton per meter square or Pascal. A wooden plank, specific gravity 0.5 of 1 meter into 1 meter into 0.5 meter, floats in water with 1.5 kilonewton load on it with 1 into 1 meter square surface horizontal. The depth of plank lying below water surface shall be how much? So it's a rectangular. This is the plank with load W1 equal to 1.5 kilonewton. Plank S is 0.5. This height is 0.5 meter. Floats in water. The depth of plank lying below water surface we have to calculate. This is submerged up to this area. This height we have to calculate. Submerged depth we have to calculate. Let it be h. H we have to calculate. So here weight is downward and force of buoyancy is upward. See total weight of the wooden plank. This is wooden plank. Weight of the wooden plank plus that load also given W1 equal to 1.5 kilonewton. So first we have to calculate the weight of the wooden plank. Let it be W2. Then we will go for total weight. So W2 is volume of plank into specific weight of plank into wooden piece. Volume is 1 into 0.5 to specific weight is 0.5 into 10 to the power 3 into G. So 0.5 square is 0.25 into 10 to the power 3, so it's 5 by 10, 5 by 10, 10 to the power 3 into 9.8, 250 into 9.8. Here we'll get 450 point here. This is Newton. So W1 in kilonewton, so 2.45 kilonewton. Then total W downward force is W1 plus W2. 2.45 plus 1.5. It will come 3.95 kilonewton. Buoyancy force is Fv equal to total W. Volume of fluid displaced into specific weight of immersed fluid, it's water. So W we already got 3.95 into 10 to the power 3 Newton. So area into depth of immersion is small h into density of water is 10 to the power 3 into 9.8, 3.95 into 10 to the power 3. Is cancel. H equal to 3.95 divided by 9.8 into area is 1 cross 1. So H equal to 395 by 100 into 10 by 98. It's 10. 395 by 98, 10. If we multiply 4 in 98, 98 into 4, 392. So approximately 4 by 10, 0.4 meter. So from option, depth of plank lying below water surface shall be 0.4. This C is our answer, 0.403 meter. Circulation is defined as the line integral of tangential component of velocity about A is center, B closed counter in a fluid flow, C velocity profile, D pressure profile. We know rotation equal to W equal to half into curl of V. So and vorticity 2 into rotation. Or 2 into half into del cross V or curl V. V vector. So vorticity is del cross V vector, curl of V. So then circulation in this question they asked. Circulation equal to vorticity into area. Then into area. Or we can write circulation is line integral of tangential component of velocity around a closed curve. So from option circulation we have to B is our answer. Closed counter in a fluid flow. This rotation also important, vorticity also important, then circulation. Unstable equilibrium of a floating body implies, we know for floating body mgb. This is for stable equilibrium. So in this question they asked unstable equilibrium. So from option A, meta center M is above center of gravity. This is for stable equilibrium. So not possible. Meta center M is below the center of gravity. This is our answer. And if meta center M coincides with center of gravity, then it's neutral equilibrium. This question was asked 3 times in Isro exam. So this is very important. Stable equilibrium, neutral equilibrium and unstable equilibrium. Viscosity had the dimension of 2 methods we can apply here. We know viscosity unit is Pascal into second. So it's Newton per meter square into second. Newton is kg meter per second square to second divided by meter square. So we'll get kg by second into meter. M, second is time, t, meter is length, so M by LT. So D is our answer. Or in second method, shear stress equal to mu du by dy, or mu velocity by distance y. From here mu equal to tau y by v. Tau is stress Newton per meter square into y is meter, v is meter per second. Cancel. Newton per second into meter square. Again we will do the same thing for second square into second per meter square. So we will get M by LT. Same answer. Which of the following flow is rotational where u and v are velocity components in x and y directions respectively? We know for irrotational flow, curl of v is 0 for irrotational. And if curl is not 0, then flow is rotational flow. So this one we have to check. From option A, del cross V equal to I j k del by del x del by del y del by del z u v w. W is 0 here, so I j k del by del x del by del y del by del z u given as y v 3 by 2 x 0 del cross v. So we will get say 0, here also 0, here 0, 0, then k into 3 by 2 minus k cap into 3 by 2, 1. 1.5 minus 1 is 0.5 k, which is not equal to 0. Flow is rotational flow. So A is our answer. No, C option, both A and B there, so B also we have to check. So for B option also we have to check the curl. So I into say 0, 0 minus 0 minus j into 0 minus 0 plus k into del by del x of x square y is 2xy minus del by del y of xy square is 2xy, so 0. Finally we will get curl is 0. So this is irrotational flow. So C is not possible, only A is possible. Thank you friends, thank you for watching my video. If you like my video, then subscribe it. Thank you.